So let's continue with the mechanism. We form our alpha-beta bond, and we have the alk oxide. So logically, we need to protonate it. That's why this is aqueous base. So we do have the water molecule that was generated in step 1. So let's use that and protonate it. The alk oxide functions as the base, plucks off the proton, and we get this important intermediate. This is called the aldol, the beta-hydroxyaldehyde, more generally the beta-hydroxycarbonyl. It's also called the aldol addition product. This all just means the same thing. The aldol is just the most general name. If you get rid of this methyl, phenyl, and this methyl, put in R groups, you have the aldol functional group. Importantly, we've regenerated the base, so this is a base catalyzed mechanism. But it doesn't stop there. This is not stable. In this case, very little heat is applied, which allows us to form the condensation product. So, ignoring the mechanism, let's compare the aldol and what's called the enal. En for the double bond, al for the aldehyde. If this were a ketone, we would call it an enone. So what do we observe? The beta-hydroxy has left. On top of that, the alpha-beta bond is now a pi bond, which means we have lost an alpha proton, which is present here. So two things are leaving here, the hydroxide and the proton. And this is a totally different elimination mechanism. The condensation is acid or base catalyzed. In this case, E1Cb is base. So let's use sodium hydroxide again. As the base, it can pluck off this mildly acidic alpha proton. That's its target. What happens then is the carbon-proton electrons travel back into the compound to establish that pi bond right here. So that's represented by this flow. What then happens is hydroxide is kicked off as a leaving group. Kind of unheard of, but that's what happens in this E1Zb mechanism. Essentially irreversible. So we repeat, hydroxide plucks off the acidic proton. The carbon-hydrogen electrons travel back and establish the alpha-beta bond, which is what we're striving to form. And lastly, hydroxide's kicked off. So we form water here and the conjugate base hydroxide as a result of this elimination. This is called the enal or enone, like we said, the alpha-beta unsaturated carbonyl in general, or the condensation product. We're all referring to the same thing. So if we just take a look, we said this is our electrophile and this is our nucleophile. We've controlled those circumstances. So the nucleophile attacks the electrophile. We can use any one of those two methods, but if we use method 1, this is what we get as the intermediate, the aldol intermediate. We form the alpha to beta bond. And upon protonation, we get this aldol functional group, the beta-hydroxyaldehyde. Now, if we do a base-catalyzed E1Cb and add a little heat, we get the alpha-beta unsaturated carbonyl. So that's the pattern here. We form the aldol functional group with these variable groups, this phenyl, methyl, this methyl group here. Essentially, it's the aldol functional group. Here, it's the enal functional group. Again, these groups are variable. But importantly, to form the condensation product, we needed this extra alpha proton. So the presence of 2 alpha protons is critical for any sort of condensation to occur. Now here's a practice problem. The first thing to notice is that we have no constraints. We're not necessarily controlling acetaldehyde as the nucleophile or electrophile. So to organize this, let's draw a table. We'll put the nucleophiles on the left and electrophiles on the right. So compound 1 can react with itself, and on top of that, it can react with compound 2. Each one of these compounds bears an electrophilic and potentially nucleophilic moiety. And same thing with 2. It can react with itself or with acetaldehyde. So 4 possible products. So let's look at forming compound 1, the condensation from compound 1. Now before we do anything, we need to draw out the 2 components for the aldol. We need to draw out the nucleophile and electrophile. So let's draw acetaldehyde twice. Arbitrarily, the right one is our nucleophile, and the left molecule is our recipient, the electrophile. Now based on this, we can very quickly draw the full condensation product by using method 1. So as the nucleophile, the carbonyl oxygen is undisturbed. So let's draw the aldehyde, which is a part of the nucleophile. And let's draw an alpha-beta bond, because that is the requirement here. And all we do now is just analyze what is bound to alpha and what is bound to beta. And then we're done. So alpha contained 3 protons, now just 2. And beta had the carbonyl oxygen. Let's put the OH here as the intermediate aldol. And we see the methyl group bound to beta, so let's put in the methyl group bound to beta right here. So this is the intermediate aldol, or the addition product. What we do then is deprotonate another alpha and kick off this OH. So basically, let's erase the OH, pretend there's only one hydrogen left here, and draw out the alpha-beta bond. And that's it. This is the final product. Now let's look at 2, 3, and 4. Now for product 2, compound 1 is attacking compound 2. So let's draw both of those out. We'll keep the nucleophiles on the right side. And just to abbreviate, let's just say isobutyl is this madness here, okay? This alkyl group is isobutyl. Alpha is attacking beta. Again, let's follow the protocol. The first step is just to draw this carbonyl as a part of the nucleophile. And then we draw in the alpha-beta bond. All we do then is analyze what is bound to alpha, what is bound to beta. So alpha doesn't contain anything. Beta had the carbonyl oxygen, which becomes a hydroxy. So let's put that in. And it also had this isobutyl, so let's put that in right here. We don't need to draw on this hydrogen. So this is our intermediate, the beta hydroxy aldehyde. Now let's do condensation. We deprotonate at the alpha position and we kick off this OH. So let's come in with our eraser, get rid of the OH, and establish the alpha-beta bond. That is the full condensation product. So if you follow the same protocol for 3 and 4, these are the products you get.